The first part of section 6.2 is really just a notation difference. You're going to learn about the notation for indefinite integrals, and you're going to be able to solve indefinite integrals. So an indefinite integral is a family of functions that are antiderivatives of the integrand f of x. This is the notation. It looks just like definite integrals, except notice that it's missing limits of integration. It's just an integral sign with an integrand f of x and then the dx. The dx tells you what variable you are integrating with respect to. It tells you what your independent variable is. And your answer will be a function of x because it's a dx integral. Your answer will be a family of functions, so you will include the plus c whenever you're solving an indefinite integral. Since the only thing new is notation, we're going to jump right to examples. So pause the video if you're still taking notes. Otherwise, we'll move on to an example. All right, here's our first example. Give it a try if you can, and pause the video, and then I will show you how I would solve this problem. Okay, so this is a power rule problem because we have an exponent that's not equal to -1, and so I would use the power rule, which is on your little bright note sheet, that little card I gave you on the first day of this unit. So I would take -2 plus 1. We add 1 to the exponent because if we were doing an integral, we'd subtract 1 from the exponent, and then we divide by that exponent. So we'll divide by -1, and then we have to have a plus c. So my final answer would be -1 times x to the -1, which would be -1 over x plus c, and that's my function that is the antiderivative of x to the -2, or the family of antiderivatives of x to the -2. Okay, oh, I wrote all over where I was going to have a problem, sorry. So this one is find the antiderivative of sine x plus e to the x, and the next one is dt over t squared plus 1. You really have to be good at your derivatives in order to be good at your antiderivatives. So what gives us a derivative of sine x? Well, that would be cosine, except the derivative of cosine is negative sine, so this would be negative cosine. And the thing that gives us a derivative of e to the x is just e to the x, and then we're going to remember to write a plus c. And I could rewrite this one a little bit as 1 over t squared plus 1 dt, and that looks a lot like tangent inverse, so it's going to be tangent inverse of t and then plus c. Again, you really have to be good at those antiderivatives. You have to be able to come up with that on your own. All right, here's a bunch of power rule stuff, except for this one is not a power rule because that's not, that is a -1, which means the power rule won't work. So for x to the third, it would be x to the fourth divided by 4. That's the power rule. X to the -1, that would be the natural log of the absolute value of x. The reason we have to put those absolute value bars around that is because you can't put a negative value into a natural log function or it explodes. So we put the absolute value bars to protect us from exploding natural log value functions. And then it would be x to the -1 divided by -1, so plus divided by -1, and then plus c. If I wanted to rewrite that a little bit, I could. I could write it with positive exponents just to make it a little bit nicer, but that's the only difference I can see. So I'm just looking for the function that gives me this as a derivative. Again, you can check your work by taking a derivative of your answer to see if you get the integrand when you do that. Okay, here's another one. Again, you have to be really good at your antiderivatives. The antiderivative of e to the x is just e to the x, but the antiderivative of 2 to the x is 2 to the x divided by the natural log of 2. The antiderivative of x squared would be x cubed divided by 3, and then plus c. The reason that we divide by natural log of 2 is because, remember, the derivative of 2 to the x is 2 to the x times natural log of 2, and dividing by the natural log of 2 is to get rid of the natural log of 2 because there isn't one in my integrand. You can always check your answer by taking a derivative of your solution. And one more. So the antiderivative of sine x would be, well, derivative would be cosine. The derivative of cosine is negative sine of x. And then the thing that gives me secant squared for a derivative would be tangent, and then plus c. Again, you could check your work by taking a derivative. Here's another one. So that's actually the one we just did, so I'm not going to do that one again. A challenge is, it looks like there was originally a chain rule that happened here. So it was something to the 5th power, and that's where that 6, something to the 6th power, and that's where that 6 came from. And so before I did the derivative, I had sine of x to the 6th power, and the cosine of x came about because of the chain rule. So plus c. We're going to learn a method in the second video for always being able to undo the chain rule, even if you're not really great at seeing it initially. So this is a kind of an informal, hey, I can see that the chain rule happened. But in the next set of videos, we will more formally do some chain rule problems. So here are a couple of more where the chain rule happened. I'll give you a minute to try to solve those, or you could actually pause the video and give yourself a minute to try to solve those. But the chain rule happened to these functions. What was the baby? What was the mama? And how can you figure out what it looked like before the chain rule happened? So for the second one, the baby was x squared. The mama was e to the x. So this looked like e to the x squared because the derivative of x squared is 2x. So if I take the derivative of that thing, I get e to the x squared times 2x because of the derivative of the baby. And this one looks like the baby was x squared plus 1. And when the derivative happened, I got a 2x. So before the derivative happened, I had the baby, x squared plus 1, to the negative 3rd power, divided by negative 3, except divided by positive 3. And let's see if that works. If I take the derivative of that, I bring down the negative 3. That's going to cancel and make that negative. And then I have x squared plus 1 to the negative 2, and then times 2x. Okay. So it takes some practice, and what we're going to do is learn a method for doing these kind of integrals using something called U substitution, which is changing our variables around so that it looks exactly like the integrals that you have on your bright yellow card. So that's our next video. This video was about that notation, that integral sign. Your solution should be a family of functions.